Okay, so here we have a ball being thrown down from the top of a 220-foot building. So it's being thrown down, so with a velocity of 22 feet per second. So what I have is the position function is negative 16t squared minus 22t plus 220. Because I know that the velocity will be negative 32t minus 22. All right, so now what is the velocity after falling 108 feet? So here, this is all of 220. So after falling 108 feet, it is 112 feet off the ground, and that's how the position function measures, is how many feet off the ground is it. So I want to find out when the position function is equal to 112. So if I set that equal to 0, minus 22t, subtract that over, oh, look at that, plus 108. All right, so if I divide through by 2, might make it a little easier, plus 11t, plus 54. Let's see, nothing's coming to mind a factor, so I'm just going to put it into my quadratic formula. So t is equal to negative 11 plus or minus b squared minus 4ac plus 4 times 8 times 54 all over 2a, which is negative 16. All right, so I see I've got a negative here, and I'm going to want the negative also because I've got a negative in the denominator. So if I put this in my calculator, oh, look at that, it does turn out to be kind of a nice number, plus 43 over negative 16. Okay, so I've got two numbers here. So for the time, so I want negative 11 minus 43, so to divide by the negative 16, and that gives me, putting in my calculator, about, 3.375. All right, that's the time. Okay, so what is it I'm trying to find again? The velocity after falling. So I put that into the velocity, so 3.375 into my velocity equation, so negative 32, 3.375 minus 22, and putting that into my calculator, that gives me negative 86 feet per second. That's how fast it's going. All right. So let's look at these. Whoops, let's get rid of that. All right, so let's look at this next question. So I've got a stone being dropped. So initial velocity is 0, correct? So v sub 0 is 0. It's dropped into a pool, and I see a splash after 6 seconds. So that means s of 6 is equal to 0. So that means the position off the ground is 0. How high is the cliff? I get no indication whatsoever whether we're talking English or metric units. So I could do it both ways. So let's go with the velocity being negative 32t, and it's being dropped, so the initial velocity is 0. So s of t will give me negative 16t squared plus s naught, and that's what I'm trying to find. So I could do the same kind of thing. Let me just put it over here. So velocity would be negative 9.8t, and s of t would be negative 4.9t squared plus s naught. So this same piece of information would get used in both of them. So if I set it equal to 0, and I substitute in 6, I get 16 times 36 is my s of 0. And what does that give me? About 576 feet. So if I do the same thing here, set it equal to 0, and plug in 6. So I get 36 plus s naught. So that gives me s sub 0 is 176.4 meters high. And those are equivalent. All right, let's finish off with one last one here. So I'm throwing up a stone at 30 meters per second from a 200-meter cliff. Okay, so I know that the position function, well, let's start with the velocity. So velocity would be, since I'm talking meters, negative 9.8 t plus 30, right, because it's being thrown up. And if I went to find the position function, taking the antiderivative plus the 200. All right, so this one here is asking us to find the maximum height that the stone has reached. So even thrown up from a cliff, it still goes up and it comes back down. So the maximum height is going to occur when the velocity is equal to 0. So that's what I'm going to do to find the time. So I'm going to set this velocity equation equal to 0 to find the time that it reaches the maximum height. So setting that equal to 0, solving, so I'll get 30 divided by 9.8, and that's really close to 3. I put it on my calculator. All right, so I'm going to put 3 into my position function. So I get negative 4.9, 3 squared plus 30 times 3 plus 200. So that gives me 245.9 meters. So that's how high it is. Shoot. Identity.